All right, continuing on with 3-3, we're going to find the slope. So here is an example, -1, -2, and 3, 3. So we're going to find the slope between these 2 points, or of the line that crosses through these 2 points. So the first thing I do, as I just did before, I label x1, y1, x2, y2, and then I use the slope formula, m equals y2, which is 3, minus y1, which is -2, x over x2, which is 3, minus x1, which is -1. And so this becomes plus, and I have 3 plus 2 is 5, 3 plus 1 is 4. And that's my slope. Up 5, to the right 4 is my slope. Now let's do a couple for you to try on your own. You try. I'm going to give you 3 actually. -2, 3, and 1, -3. Also, -4, -3, and 3, -3. And 2, 1, and 2, -4. All right. Do those 3, and then we will take a look at them together after you're all done. So go ahead and pause and get to work on these guys. All right, let's see how you did. I'm going to label first x1, y1, x2, y2. Y2 is -3, y1 is +3. Wait a second. Did I do something? Yes, that's right. -3. -3. X2 is 1, x1 is -2. Oops. 1 minus -2. Okay. So that gives me -3 minus 3 is -6 over 1 plus 2, which is 3. And then if I get a fraction here that I can reduce, I need to reduce it or simplify. -6 divided by 3 is -2. My slope is -2. Now let's look at this one. x1, y1, x2, y2. Always label first. y2 is -3 minus y1, which is -3. x2 is 3 minus a -4. So up on the top, I've got -3 plus 3, which is 0, and 3 minus a -4, so that's 3 plus 4, which is 7. 0 over 7 is just 0. So the slope is 0, and we're going to look at what that looks like down here at the bottom of the page in just a minute. But let's look at this last one first. x1, y1, x2, y2, -4 minus 1 over 2 minus 2. -4 minus 1 is -5, and 2 minus 2 is 0. Now, I have 0 in the denominator. No, I cannot have the 0 in the denominator. This is undefined. And we'll talk about what that looks like in a moment. And that moment has arrived. Classifying slopes. So remember, when we're looking at a line, we're reading left to right on a graph. So let's draw a few graphs. Coordinate plane like this. If the line is going like this, left to right, it's going up, then I've got a positive slope. If I have another coordinate plane, and if I read this graph left to right, and I see from left to right it's going down, I've got a negative slope. So for instance, this -2 would look something like this. It's a negative slope. Now we've got 2 more. Now I might have something like this, a line that goes parallel with the x-axis. This might be 1, 2, 3, 4, This might be y equals 4 as an example. And this has 0 slope. So that's like this one here that we looked at. It has 0 over 7, 0 slope. Notice how y is -3 here and y is -3 here. The x values are different, but the y values are the same. That's what's happening here. The x values are going to be all these different values, but y is always going to be 4 on this line. So we have 0 slope. It's not going up or down. Now here's the last one we're going to look at. And we go 1, 2, 3, 4, 5. Why not? Let's put a line right there, parallel with the y-axis. This an example for this one would be x equals 5. That's what we did there, x equals 5. Now, in this instance, you're going to see when you do the slope, it's going to look something like this, where the 0 is in the denominator. This is undefined. Also, you might see it as no slope. No slope. But undefined is really the best way to talk about this. So we've got 0 slope and no slope. Those are two different things. But undefined is kind of a better way to say that. But we see it as no slope sometimes as well. So this is just a vertical line, x equals 5 or x equals whatever the number is. That's going to have no slope or undefined. All right, let's look at a few other applications of this. Some slope stuff that is review from Algebra 1. Slopes of parallel lines are equal. Slopes of parallel lines are equal. So here's my example. Y equals -4x plus 5 and y equals -4x minus 2. So this is slope-intercept form, y equals mx plus b, y equals mx plus b. So my slope is right here, that's my m. And right here, -4, notice they're both the same. So I've got equal slopes. And so this is an example of parallel lines. These equations represent parallel lines. Slopes of perpendicular lines are opposite reciprocals. And so the product, if you were to multiply the two slopes, the product should be -1. If you were to multiply the slopes that we're talking about. So here's an example of what opposite reciprocal is. If I have 4, the opposite would be -4. The reciprocal would be 1 over 4. So the opposite reciprocal is -1/4. And if I was to say 4 over 1, which is 4, times -1/4, which is the opposite reciprocal here. If I were to multiply those straight across, I get 4 over, or -4 we'll say, over 4 equals -1. So that's the product of the reciprocal that way. Now, we've got a little bit farther to go here. We're going to find the relationship of line AB to line CD. Notice they are lines because they have little arrows on either end. So we're going to see two different examples here. So A is 14, 13, B is -11, 0, and then C is -3, 7, and D is -4, -5. We're going to show the next problem too. This is probably going to be a U-try. We'll do this one together first. A is going to be 1, 1. B is -1, -5. C is 3, 2. And D is 6, 1. All right, so we're going to look at these two. We're going to find the slopes, and we're going to see if they are parallel or if they are perpendicular or if they are neither one. So if they're parallel, the slopes are going to be the same. If they're perpendicular, the product is going to be -1, as in they are going to be opposite reciprocals of one another. So what we're going to do here is find the slopes of these lines here, line AB and CD, and then we're going to examine what the slopes are. So x1, y1, x2, y2. We're going to do the slope of the line AB first. So 0, so that's y2, minus y1, which is 13, over x2, which is -11, minus 14, which is x1. So I've got -13 over -25, which is 13 over 25. So that's the slope of AB. All right. Now we're going to find the slope of CD. x1, y1, x2, y2. So y2 is -5 minus y1, which is -7, -4 minus -3. All right, -5 minus 7 is -12. -4 plus 3 is -1, so I've got +12. Now you can see these are not opposite reciprocals of one another, 13 over 25 and 12. They're not the same, and they're not opposite reciprocals. So these are not parallel or perpendicular, neither one of those. Let's do this next one. So I'm going to have you find the slopes, compare the slopes, decide if they are perpendicular or parallel or neither. All right, go ahead and pause and do that, and we'll get back to work together in just a second. All right, here we go. x2, y2, oops. Oh, well, I'm just going to leave it. x1, y1. Guess what? It doesn't matter. As long as one point is the 2's and one point is the 1's, it doesn't matter which point is which. x1, y1, x2, y2. So if you did it the other way, don't erase anything. Let's just see if your work matches my work or your answer. Your work will be just a tad different with the negatives. But anyway, you'll see the answer should be the same as far as the slope goes. All right, y2 is 1 minus y1, which is -5, over x2, which is 1 minus x1, which is -1. So if these were switched with you, this is going to look a little bit different, but in just a moment, your answer should look the same as mine. 1 minus a -5 is going to be 6 over 1 minus a -1 is 2. So 6 divided by 2 is 3. You might have ended up with -6 divided by -2. So either way, we both get 3. Now let's do this one here. y2 is 1 minus y1, which is 2. x2 is 6 minus x1, which is 3. 1 minus 2 is -1. 6 minus 3 is 3. 3 and -1/3, those are opposite reciprocals. These two lines are perpendicular to one another. Yay! And that is the end of 3-3.